In Chapter 9, we are going to talk all about quadratic formula, quadratic equations, quadratic graphs, all this stuff. So everything quadratic, and if you take a quick look down here, that means we're talking about something that has x squared. And if you see x squared as the highest degree, you're going to end up with a parabola of one sort or the other. So we break a couple things down in the bottom half here. And what we notice is we want ax squared plus bx plus c. We know this from factoring trinomials, factoring quadratics. A cannot be 0 because we know anything times 0 is 0. So that gets rid of our squared term, which makes it linear again. So real quick connection we make, if it opens up, that means that a must have been greater than 0. And that means this point down at the bottom, we call that the vertex. Okay, so that's going to be the minimum point. So if we use these two, one and the same, we'll say, find me the vertex of the parabola. I'll say also, find me the minimum of the parabola. The other thing we have is this dashed line right down the middle, and that's the axis of symmetry. So we can release that on both of them here. So real quick connection, if something is greater than 1, that means it's positive, or greater than 0, that means it's positive, and positive people tend to be smiling. So make that connection. So A is positive, it should be opening upward. If it opens up, then it has a bottom, it's a minimum. So everything in reverse. Alright, so we have vertex. In this case, it's the maximum point, so vertex and max. A is less than 0, which means it's negative, and negative means it's going to open down. We still have the axis of symmetry, which would go right down the middle. So, having given you all this vocabulary, what in the world am I going to ask you to do with it? There we go. Whoop, a little fast there. Alright, so we're going to answer a couple questions. So what are the coordinates of the vertex? So if I look through here, it stops, it comes back up. So that must be the vertex. So -2, -3, looks like C. The vertex in this case is the lowest point, so it makes that the minimum value. Okay, that is the very lowest value we're going to get out of this parabola. So what is the vertex of the graph, and is it a minimum or a maximum? Well, I here see the bottom. And 0, 2. One common practice we have, instead of just listing it as an ordered pair, we'll put a V in front, meaning vertex. The vertex is 0, 2. And since that's the bottom, that is a minimum. Up here we have 0 paired with 3, so that is the vertex. And since it's opening down, this is the highest point, or the maximum value. We want to graph the function, so that means we're going to start by making a table. So we're going to plug in some values like -1, 0, and 1. So I have -3 times -1 and squared, so that's 1, so it's -3. 0 goes in, we get 0, and 1 goes in, we get -3. So we start to get an idea of what it looks like. It's going to have 0, 0. At -1, it's going to be at -3. And at +1, it's going to be at -3. So we also know from the a value being -3, it should open down. Okay, so we know it's going to open downward. And we have that. So what's the domain? Well, these are my x values and these are my y values. Keep in mind that these are going to continue going on forever and ever. So my domain values is all real numbers. My range is a little bit different, so that's talking about the y values. Range is only when y is less than or equal to 0, because our highest point is 0 for the y-axis. I'll cover everything else down to -infinity. This will keep going and going and going. So same thing, let's use +1/3. So I know it's going to open up because it's positive. And we'll make a real quick table, -1, 0, 1. If I put in -1, I get 1/3. If I put in 0, I get 0. If I put in 1, I get 1/3. So we get the same thing. This will look a little bit different though, because at -1, we've only gone up 1/3. And at +1, we've only gone up 1/3. So we see that same shape, but it's going to be really, really wide. With the domain x values, domain is all reals. There we go. And the range, this time since we're opening up, we have all the values y is greater than or equal to 0. Widest to narrowest, so we're looking at that a value. So I have -4, 1/4, and 1. So regardless of being positive or negative. So we're going to throw that out. So how we throw that out is we talk about the A value is the absolute value of A. So as the absolute value of A increases, the graph gets more, and what does it get? So what I'm doing is I'm looking for the smallest number, 1/4. That's the smallest number, and that is the widest. The next smallest number is 1, so that's number 2, and then 4. Remember, we're talking about the absolute value, so that's the third one. So as the absolute value of A increases, the graph gets more narrow. So if I want to list these from widest to narrowest, I'm actually using the number 1, 3, and 1/3. Again, I don't care about if it's positive or negative. That just means it's going to open up or down. So the widest is going to be 1/3 from the negative 1/3. Next is going to be the 1, and 3 will be the third one. Okay. Widest to narrowest. Now what happens if we take and add or subtract a number on to the end? Here's what's going to happen. Let's go through, we know 0, and we'll go through the first column first. So 0 gives me 0, negative 1 gives me 1, negative 2 gives me 4, right? Negative 2 times negative 2. 1 gives me 1, 2 gives me 4. So let's get those on there first. 0, 0, 1, 1, and 2, 4. We also know we're going to use negative 2, 4, and negative 1, 1. So I start to get a picture of, oops, that one snuck out there a little bit. Don't use that one. Okay. And you get a picture of our parabola. Now if I plug in negative 2, I get 1. Negative 1, so that means I get 1, so I get negative, so I get 1 here minus 2, so negative 2. If I plug in 1, I get negative 2, and if I plug in 2, I get 1, right? 2, that's 2 squared is 4, minus 3 is 1. So here's what happens, is I'm going to take that exact same parabola and see what happens to it. Negative 2, I get 1, and positive 2, I get 1. Alright, so I got an extra point in here I shouldn't have. Alright. So we see that if I were to draw these exactly uniform, see this one actually fits right on there. Pretty cool, right? Because that minus 3, all it's doing is it's making the graph move down 3. Because it is minus. Notice with all your points for the y value is minus 3. 4 minus 3 is 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. Okay, same idea. So if I understand that this makes a parabola, I can start to move these things up or down. And the last thing we'll do is actually apply it. So if an acorn drops from a tree branch 70 feet above the ground, so here's the function that they give us. H is the height in feet after t seconds. So we're going to work on seconds and height. So after 0 seconds, it's still in the tree, so that's at 70. After 1 second, we're at 54. So we plugged in negative 16 times 1 squared plus 70. We got 54. 1 second is 54. 2 seconds means we're going to have 2 squared. We're going to have 6 feet, so 2 is at 6 feet. And 3 is going to be at negative 74. Negative 74, so that's going to be way down here someplace. Alright, so here's what's going on. Is this acorn has fallen down. And what are they asking for? First, what's the graph look like? Check, got that. How about what time does the acorn hit the ground? Well, if it's 6 feet here and it's negative a whole bunch there, it's definitely closer to 2. So we can say it's definitely less than, the time is between 2 and 2.5 seconds. And then tomorrow I'm going to go through how to get exactly what time, and we'll solve it that way. But just to give you an idea of what's going on there. Alright, so what we're going to do is go through, try and get definition and an example or a picture of it in your own words, trying to build that vocabulary. And then, of course, we'll do just a little bit of homework applying some of those things we just talked about. So widest to narrowest, same, different, another acorn, except this time it's coconut, and just a couple of do you understand. So we'll check these out first thing tomorrow, and bring in your questions. That's what I'm here for.